So hello and welcome back to another video, and today, well, we have a rock, and this is an Ignimbrite, or the actual formation is this one, and it classes Eutaxitic, so that's the, sometimes, this doesn't seem to have it, probably because of the way it's been broken. It's just the way it's actually formed. So crystal bearing, so crystals, here we have feldspar, fine ash, vitric tuff, so that's the matrix. So this is fine ash, and you can see this is glassy in texture, and it is a Jikusan formation, and it's Cretaceous. So this overlays the actual Kowloon granite, which presumably lay underneath. It's pale grey, tacky to rhyolite. So tacky is pretty much just a size of the crystal. Okay, vitric tuff. Okay, welded tuff, crystals, quartz, and feldspars. So the quartz will be probably a greyish colour, feldspars are white. Fabric or taxic thickness in some places 500 meters. Obviously, like you've got a volcano, and then on the side you have the actual pumice and ash that forms the actual side of the actual volcano. So this will be the main vent, and then you got the caldera, then you got the sides, which this is what that is. It's the actual sides of the volcano. Not only that, but you also got fine ash, which would have been deposited like 10-20 kilometers away from the volcano as well, depending on which way the airborne goes. So you got fine ash. So this will mainly coarse and also pumice. So the logical conclusion is that when it's more coarse or pumice, the closer to the actual vent. When it's more fine ash, it will be a lot further away, because obviously the smaller the particle, the less energy you need, so the longer time it can be suspended in the atmosphere. Okay, we've got pumice, which is just large blocks of vesicle rich volcanic rock, and they got fiame, which fiame looks a bit like this, but this one just looks like a large crystal. And here we have another feldspar. So this is in this one, it is a feldspar rich vitric tuff. And here it looks like we have some quartz. So quartz there, and quartz here. It looks like we might have some, no, it doesn't look like micas. It looks like amphibole. So why are these crystals in the actual plume? So what I've read is that these crystals probably had already formed in the magma because it was cool enough, and then when there was probably a explosive event caused by water seepage into the actual magma, and it caused the actual volcano to explode, which throughout a lot of this actual feldspar. So this is probably a plagioclase, so calcium or sodium rich. And if it's orthoclase, usually it's a reddish colour, purplish. So it's actually quite nice. So am I going to keep this? No, I'm just going to get rid of it. No point keeping it. I can't take it back to Australia. They'll go, yeah, you can't bring that into Australia. And as you can see, it looks like a nice beautiful crystal.